Hi, so we are Team Pac-Champs and we have implemented a couple of algorithms for the Pac-Man Capture the Flag competition. I'm going to speak about it now. Well, we have implemented two techniques. One is Monte Carlo tree search along with heuristics, and the other one is a Q-learning technique. To start with, the first one we did was a Monte Carlo with heuristics. Explaining that, so what our offensive agent essentially does is it finds all legal actions. Then it filters out actions leading to ghosts and dead ends. Further in, it takes the food and capsule actions, feeds it into the Monte Carlo simulation, fetches the weights, and then the action with the most weight is chosen. And finally, it finds the nearest food, eats, and returns home. After that, we also have the defensive agent, where essentially what it does is guards the center. Why have we chosen the center is it stays at the boundary and then it can optimally reach the top and the bottom part of the maze whenever it has to reach an opponent. So it patrols the center point. If it observes an enemy returning, it chases it with the shortest distance, eats it, and then comes back to its patrolling point. So along with the Monte Carlos, we have implemented a heuristic approach to optimize the Monte Carlo search. So what our heuristic function does, is that it uses linear regression techniques based on the current modes of the Pac-Man, where the features that we have used are how the offensiveness of the agent, the score of the successor move, the distance to food, along with the distance to ghost. So the features along with the weights based on the mode are fed in to the heuristic approach. And finally, all of these are fed in combined with the Monte Carlo technique to get the most optimal move. Then, so the next technique that we implemented is a Q-learning technique, where Q-learning has been used along with A-star in the offensive agent, where again, it finds all legal actions, it filters out actions leading to ghosts and dead ends. Those features and weights based on the Q value are fed in. Then the action with the most weight is chosen. And then, well, finally, the agent finds the nearest food, eats, and avoids ghosts. There is also a defensive agent that has been implemented for it, but we have not really spoken about it because it wasn't the best implementation found. Anyway, moving on. So we ran a few experiments where we compared our Monte Carlo heuristic with our Q-learning and baseline, and it can clearly be seen that the Monte Carlo is the most effective, and that is why we picked it for implementing and submitting into the final competition. Finally, the challenges we faced are we had to run a lot of iterations of the Monte Carlo technique to find the most optimal weights for our implementation. Then also, the Q-learning implementation took longer to take decisions and it failed in some layouts because it was too slow to take those decisions. The third one was to fix an optimal depth for our Monte Carlo implementation. It took a lot of iterations again to do that. And the most important one is the Monte Carlo agent, even after trying to avoid those alleys, could not avoid the deeper alleys, making itself vulnerable to get killed. The future improvements that we can do are to implement a deep Q-learning approach, improve the Q-learning approach to speed up the decision process, find trap positions to avoid getting stuck in alleys, and also use a defense agent as an attacker, using it as a hybrid offense and defense. Alright, so now let's have a look at the demo for our Pac-Man implementation. This is our Monte Carlo offensive agent whose major goal is to eat food and then come back home to register its score. So as you can see, it keeps eating food and then it finds a path back home to register it. And then when it sees a ghost around it in the opponent's zone, it finds the shortest distance between a capsule and a ghost. If it finds the capsule, eats it, and then keeps eating food again. So this is our Monte Carlo defensive agent whose major task is go to the center, keep patrolling there. And then once it finds an opponent, it keeps chasing it. Once it is done and then kills the opponent, it comes back home to its patrolling point. One of the limitations of our agent is essentially a trap zone where our agent enters an alley, tries eating food, but then the opponent manages to chase it and kill it within the alley. And there you can see it gets killed. So this is our Q-learning implementation, which uses Q-learning for its offense and a special technique for its defense, where it essentially finds an alley and blocks it so that the opponent cannot come and eat all of the food. To finish all of the food, it has to enter that alley and essentially will get killed. Unfortunately, this implementation does not work for our competition, where a partial win also works. Also, our Q-learning agent takes a lot of time to take its decisions, which can be seen in the slowdown in the video. That was it for our demo. Thank you very much.